So, good evening. This is Syed Uzair Naqvi, roll number 61, and today we'll be discussing about the week 2, day 3 of EDA, which is the sparsity and correlation when feature selection gets tricky. So, let's go. So the first things first, we'll be importing all the important points like all the important libraries such as NumPy, Pandas, sklearn, and in sklearn we'll be also implementing the linear model, pre-processing, pipeline, and model selection. So I have to remember these four in sklearn. So let's go. We know the all the processes what it actually does. Like Pandas is used for the numerical operations, as we can see it here, and the pandas is used for data frames, make the data tables. And the linear model lasso is like L1 model, we call lasso for L1. And pre-processing standardization is for scaling, we are just making it generalization so that we are able to do more calculation on it, so it is generalized. So in that, and model and pipeline is for like pipeline, the whole pipeline thing. So let's continue. As always, generate the data. We are building the features, run the EDA. So this is the whole first milestone. And the milestone one, we are doing the high dimensional setup. So in this, I create a data set with many features, but only a few truly relevant ones to show why feature selection matters. Why feature selection matters. So in that, the observation is that, so we can see here that there are total of 30. Well, we can see that there are total of 30 features. Yeah. But only three have non-zero true coefficients, as we can see it here. So this is the first milestone, and we have also observed that. So the interpretation of the whole milestone one is that in high dimensions, irrelevant features increase variance, and reduces interpretability. And lasso should shrink irrelevant features to zero. So I'll take a little bit more time because, okay, let's continue. So we'll be checking the milestone 2, which is the correlation structure. So the correlation structure, so the first what we are trying to intend is that I inspect the correlated features to understand how correlation complicates selection. So from this, we can observe the x1 0 x0 x1 x2. We can see that what are the correlation between x0 x1 and x2. So like from this we can see they are very highly correlated to each other because of the numbers that we can see, they are very close to each other. So from this we can interpret that the lasso may arbitrarily pick one and drop the other because correlated predictors shares information. So as we can see from this is very simple. As we can see it on the result on the table, and the milestone 3. In the milestone 3, we are doing the elastic net like lasso. This is the thing. So we are doing the elastic net motivation. So in this, we see that I explain when elastic net is preferable. So from the result, we can see the number of zero coefficients is 23. So we can see that high correlation among relevant predictors motivate grouping behavior. So for example, if they are very highly correlated to each other, meaning that they relate to each other a lot, that means they will form a group. So that motivates them to actually form this kind of group because they are very similar to each other. They correlate with each other. So from this we can interpret that the elastic net balance L1 sparsity with L2 stability, allowing correlated features to be selected together. So thank you. This is Syed Hussain Naqvi, roll number 61, signing off. Have a good day. Thank you.